Hello and welcome to Train Signal. You're watching video number 20, Administering Hardware. This is part of Fast Track CPT Video, Linux Networking and Administration. In this video, we'll talk about configuring peripherals in Linux, understanding hardware resources, diagnosing hardware resource issues, removable hardware, power management, and mass storage. So we'll start with configuring peripherals. Now Linux Plus Objective 1.12 says you should be able to configure peripherals as necessary. They say example is a printer, a scanner, or a modem. So first off, printers in Linux are usually either parallel, USB, or Ethernet network devices. So a parallel or a USB printer would connect directly to the PC. Many times today these are USB much more than they're parallel. Ethernet network devices would be a device that's directly on the network connected to a hub or a switch. It has an IP address and your computer's talking to it over the network. Then you have scanners. Scanners in Linux are usually either SCSI, USB, or FireWire. FireWire is the IEEE 1394 standard. So you're going to connect a scanner with either a USB cable, a SCSI cable, or a FireWire cable. So these are all directly connected to your PC or server. Now the most important thing to know about using a printer or scanner in Linux is whether or not there are drivers for your version of Linux that support your device. A good database that you can use to check your hardware's Linux compatibility is located at this website, www.linuxcompatible.org/compatibility.html. So here you can go through, you can find your hardware manufacturer and the model of device and see if it's compatible with Linux. So that's the most important thing you need to know about using devices like printers and scanners in Linux, is can you find a driver for them for your version of Linux? And if not, can you find the source and can you compile the source in Linux? And, is that going to work? So if you stick with a industry compatible, piece of hardware that works in Linux, you need to make sure that it works with Fedora. Let's say if you're using Fedora, or SUSE if you're using SUSE. Now there's another program called, or a system I should say, called SANE. SANE stands for Scanner Access Now Easy, and it's the most common Linux scanner tool. It comes installed in Fedora 5 by default, and the home page for SANE is sane-project.org. So this is a tool to really make scanning in Linux much easier. And the general SANE applications used by users are sane-find-scanner and scan image to actually scan an image from the scanner. So SANE is a great system to make scanning in Linux easier. Now serial devices in Linux are called TTYs. They're found in the dev directory, as is every other Linux device, and you can configure them with the set serial command. So an example of a serial device would be an external modem that you plug into a serial port. You could also have serial devices that you're using to connect to Linux Plus Objective 6.1 says you should be able to describe common hardware components and resources, for example connectors, IRQs, DMA, SCSI, and memory addresses. Now hardware components must interface with the motherboard and then the operating system using some sort of communications channel. So the hardware resources discussed in this slide are all types of communications channels. So when I say hardware resources, I'm talking about these here: connectors, IRQs, DMA, SCSI, memory addresses. These are all types of communications channels, or communicating some piece of information between the memory, the hard drive, and the CPU. Now you have your connectors, and most of these connectors match up with some sort of protocol. So for example, you have Ethernet. Ethernet's a protocol that you use on your local area network to connect devices like PCs, servers, printers, routers, switches, hubs. All those things use Ethernet. But then for a connector, you have an RJ45 Ethernet jack. So that's the type of connector you connect with. You call it an Ethernet cable, but on each ends there each end there's an RJ45. You have the SCSI protocol. SCSI is used for disk drives, but then you also have SCSI cables that go along with that, right? Then you have ATA. ATAs for disk drives or CD-ROMs. Then you have ATA cables. You have USB and USB cables. You have RS-232, which is a cable type or an end of a cable. And then you have serial that goes along with that. You have parallel and parallel cables. So these are all important to understand when troubleshooting hardware. What type of cable goes with what type of protocol and what type of connection would it have on the end of the cable. Then you have IRQs. Now IRQs are commonly called interrupts, and they're used to signal the CPU that they need attention. So it's a transmission or a communication method to tell the CPU that, hey, I need some attention. Now every device that uses an IRQ must have a unique IRQ, except on PCI motherboards where IRQs can be shared. Now IRQs are hardware resources on the motherboard of the computer, and x86 systems support 0 through 15 or 16 interrupts, but 2 and 9 are the same, so you can't use both of them. You have to use one or the other. Now then you have DMA channels. Now a DMA channel is a direct memory access channel, and it's used to perform a block transfer of data to and from memory with little help from the CPU. So with a DMA channel, you can directly connect to the RAM or the memory of the computer and put something in memory. So these devices are using DMA channels to put things in memory. They're using IRQs to communicate to the CPU and say, hey, I need some attention. And then you have I/O ports. An I/O port is an input-output port, and they're memory areas of devices and CPUs used to exchange data. So some common hardware resources are listed here for a parallel port and floppy disk controller, and there's a long list of other devices that commonly have IRQs, DMAs, and I/O channels associated with them. So these are sort of the standards or the defaults. You can go in and change what device uses what IRQ, what DMA channel, and what I/O port, but you're playing with fire there because there's standards that are set up, and if you change, say, the parallel port from IRQ9 to IRQ6, well, then you're overriding the floppy disk controller. So the parallel port is commonly called dev LP0 in Linux, uses IRQ9, uses DMA3, and it uses these I/O ports down here. They're listed in hex. Then you have a floppy disk controller. It uses dev FD0, IRQ6, DMA2, and these I/O ports. And you can look up the standard list of what devices use what resources. But there are many types of devices that don't have a standard, and you have to make sure that they don't conflict with other resources. So if you install a Sound Blaster sound card, it might write over one of these other resources here, and then they both don't work. Either one works or the other works, or neither one of them work maybe. So this is something you need to understand when it comes to troubleshooting hardware. Our IRQs, DMA channels, and I/O ports. Now let's move on to diagnosing hardware issues. Now Linux Plus Objective 6.2 says you should be able to diagnose hardware issues using Linux tools. For example, they talk about the /proc directory, disk utilities, the ifconfig command, the dev directory or file system, and live CD rescue disks, and then the dmessage program. So now let's discuss some common Linux files and tools that are used to diagnose hardware issues. First off, you should always make sure that the hardware that you're having an issue with is compatible with your system. You can do this at this Red Hat hardware website. It's a hardware certification website, and it really talks about Red Hat Enterprise Linux, but it also applies to Fedora Linux, the free version of Red Hat Enterprise Linux. Now, additional hardware how-to information can be found at this website. This is the Linux Documentation Project, and besides hardware how-to, there's a ton of other great Linux documentation you can find at this website. So, the Linux Plus objectives mention the proc file system. The proc file system is where much of the hardware information in Linux is held. So the proc interrupts directory is where you'll find IRQ information. The proc DMA directory is where you'll find DMA information. The proc IO ports directory shows IO port information. But these files only display information about active devices. Now, when you turn on your system and it starts to boot up, the first thing it does is the post test. This is the power on self-test. This is the test that tests things like CPU, RAM, and the presence of a keyboard or a video card. So out of the post test, if one of these things isn't functioning, all you'll hear is a series of beeps when your computer turns on. So this tests the very basic, the most minimal hardware devices that would be found on your system. Now, once the system's booted up and working, a command that you use to test disk performance is the hdparam command. For example, the hdparam-t/dev/hda command would test your hard disk performance and its transfer rate, so it would tell you how fast it can send and receive data to the hard drive. This command can also be used to change parameters on your hard drive or disk controller, such as enabling DMA mode transfers. So this can be used to configure and tweak your hard drive performance, and it might be able to increase performance, or if you don't know what you're doing, it might decrease performance. Now, another important disk tool is fdisk. We talked about fdisk in our disk management video, but fdisk is used to partition the Linux hard drive. Now, when trouble does occur, you can use an emergency boot disk many times to get your system booted up so that you can access your hard drive and maybe change some configuration files. So think of this as like a rescue disk or an emergency boot disk. You can download a CD called Knoppix. It's a standalone bootable Linux CD. You stick it in your drive, it boots up, and you're running Linux, but entirely without your hard drive, just from your CD drive. Once you do that, you can mount your hard drive, your Linux hard drive, and go in and make configuration changes. So it's a great tool to have lying around. You can find it at knoppix.org. A couple other cool tools are found at this MU-Linux and toms.net. These are both tools or Linux versions of Linux that run on floppy disks. So you can stick a floppy disk in a floppy disk drive, boot up a Linux version actually on a floppy, and then mount your hard drive and go in and make changes to configuration files. So those are some really cool utilities. I don't think anybody's ever got Windows on a floppy disk, that's for sure. So you can run Fedora from a USB disk drive, and you can actually copy a functioning version of Fedora, put it on a USB disk drive, plug it into a PC, and boot up through USB. And you can find information on doing that at this website here at Linux Forums. Now, another important Linux command is dmesg, D-M-E-S-G. This is a program that shows Fedora boot up messages. This is great for troubleshooting non-functioning hardware, as you may be able to see an error message concerning that non-functioning hardware from when the system booted. So the system boots, it goes through, it does a bunch of things, right? All these messages and alerts appear on the screen and they scroll by real fast. Well, maybe one of your devices wasn't working. You can go in, use dmesg to see what the log files contain about when the system booted. This file is also stored in var log, and there's files called boot.messages, and then the older ones are boot.messages.1, 2, 3. In our networking configuration video, we discussed the ifconfig command, or ifconfig. This is a program a lot like ipconfig in Windows, but this program can actually show and configure your network adapters. Now, some other important Linux hardware troubleshooting commands are lspci. This lists information about the PCI bus and the PCI adapters on your system. There's lsmod. This lists kernel modules that are loaded, and it's essentially displaying information found in the proc modules directory. There's the modprobe command. This is used to add or remove kernel modules and change their order. Then there's a couple of the commands here that I threw in that may or may not be associated with hardware troubleshooting, but they're pretty cool commands. There's lsof, which is used to list open files by user. Then there's the strings program, which is used to show what readable text is found in a binary file. So you have these binary programs out here. You can do strings on that file name, and it'll list any ASCII text that's found in there. So we learned a lot about diagnosing hardware resource issues in Linux. Now let's move on and talk about removable hardware. Now Linux Plus Objective 6.3 says you should be able to identify and configure removable system hardware. For example, they mention PCMCIA, USB, and IEEE 1394, which is also FireWire. Now there are a variety of different connectors or protocols for removable hardware. Let's review the major types. And we're going to review these three major types here: PCMCIA, USB, and IEEE 1394. Now PCMCIA is the Personal Computer Memory Card International Association. That's what it stands for. It's a lot easier just to say PCMCIA. That in itself can be a challenge sometimes. But PCMCIA is the replacement for a PCI card slot on a laptop. So on a regular PC you have these PCI cards, and if you want to add a network card or a SCSI card adapter, you put your PCI card in there, and that gives you that additional capability. But on laptops they don't have that much space to add these PCI cards. So they created this PCMCIA card, and they're much smaller than a regular PCI card, and you can insert that into your laptop. So many times this is called a PC card or the card bus. Now there's three different sizes of PCMCIA cards. There's type 1, 2, and 3, and each one gets increasingly larger. Type 1 and type 2 are much more common than type 3. Type 3s are actually really large. Linux isn't too keen on PCMCIA, but it is supported, and you can perform some configuration in the etc PCMCIA directory. The next type of removable hardware is USB. USB is the Universal Serial Bus. Now drivers are required for USB devices, so you must make sure that they're available and compiled for your version of Linux, or you'll have to download the source if it's available and compile them yourselves. So just like any other Linux hardware, just make sure you can get drivers for your version of Linux. Now, USB disk drives are treated like SCSI disk drives, and there's a special directory for USB called /proc/bus/USB. Out of all three of these here, USB is the most common form of removable hardware in use today. You can get USB devices that do all sorts of things. USB disk drives, CD drives, DVD drives, tape drives, all sorts of USB devices. The last type of removable hardware is IEEE 1394. This is a standard for FireWire. FireWire is similar to USB in many aspects, and it's very popular for video transfer and some disk drives. However, USB is becoming more and more popular than FireWire. For information on using FireWire devices with Linux, you can go to www.linux1394.org. Now let's move on and talk about power management in Linux. Linux Plus Objective 6.4 says you should be able to configure advanced power management and advanced configuration and power interface. That's ACPI. That's what this Advanced Configuration and Power Interface is, ACPI. Now, power management is much more important on laptop computers than it is on desktop or server computers. So usually when you're dealing with power management, it's because you're on a laptop and you're concerned with, of course, the battery running down. So you want to manage the power. On PCs and servers, generally people don't care too much about power management. Power management includes dimming the screen, slowing down the CPU, pausing the hard drive, or putting the laptop into suspend mode or hibernate mode. Now there are two sets of power management tools. One is the ACPI and the other is the APM. ACPI is the Advanced Configuration and Power Interface Standard. APM is the Advanced Power Management System. Now, these two sets of tools are similar, but their configuration is different. Both require that the computer's BIOS supports them. So if you have a laptop, your BIOS has to support ACPI, or it has to support APM. So to use either one, you have to know which one your BIOS supports, and that's the one that you're going to use. Now both APM and ACPI have their own daemons called the APMD or the ACPID. Now the ACPI in Linux configuration is located in etc ACPI. You can the best thing to do to configure power management in Linux is to use the GNOME Power Management System. The GNOME Power Management System has a GUI interface, which makes it much easier than configuring any of these text files, and you can run it either from the graphical interface in Linux. I'll show you how to do that in just a second, or you can just type in gnome-power-preferences at the command line, and it'll bring up the GUI interface. Let's go check this out for just a second. So I'm over here on our Linux server. I'm going to go up to System. I'm going to go to Preferences. And then over here I'm going to go into More Preferences. Then over to Power Management. If I click on that, it brings up this little Power Management Preferences program. So it says I'm running on AC, and what am I going to do here? When am I going to put the computer to sleep, if it's inactive, for how long, and am I ever going to put this computer to sleep when it is inactive? And here it's set to never. I can move the slider back and forth here. I can go over to options, and in general, sleep time when inactive, I can do nothing or hibernate. I can have an icon. So it's a pretty simple little utility here, but this is the GNOME Power Preferences GUI interface. Alright, so we're back at our slides, and now let's talk about mass storage in Linux. Concerning mass storage devices, Linux Plus Objective 6.5 says you should be able to identify and configure mass storage devices in RAID. For example, you should be knowledgeable about SCSI, ATA, PI, tape, optical, and recordable devices. Now, ATA devices are the most common type of mass storage device in use today. ATA stands for Advanced Technology Attachment, and it's used for hard drives, optical, and tape devices. Now, there are a variety of different speeds of ATA devices and a couple different types. First off, there's parallel ATA or PATA devices. These are older and they use 40 or 80 pin cables. They're now more popular than PATA devices are SATA devices or serial ATA devices. SATA devices have no master-slave configuration, and they have just one device per cable. The type of interface used with ATA devices is called an ATA-PI or ATAPI, and ATA-PI stands for Advanced Technology Attachment Packet Interface. Now in Linux, ATA devices are named /dev/HDX, where X is a letter like A, B, and so on. The next technology is SCSI. SCSI stands for Small Computer System Interface. SCSI devices are generally on higher performance machines like servers or high-end workstations. Most common PCs and low-end servers today don't use SCSI. There are a variety of different speeds of SCSI, and now each SCSI device, including the host adapter, has a numeric ID number, and they usually range from 0 to 15. SCSI devices are daisy-chained together. That means that one is connected to the other, and they must be terminated with a terminator. Sometimes there's automatic terminators. Most devices today have automatic terminating functions on them. but older devices would have to have a terminator that you would actually plug in at the end of the daisy chain. Now, tape, optical, and recordable devices will all either be SCSI or ATA. Each will have its own unique device name, like in the dev directory, but other than that, they'll connect just like a hard disk drive. For example, a tape device is usually a /dev/MT0, MT standing for mag tape or magnetic tape. An optical device might be dev CD whatever. A recordable device could be a USB device like an HD, or it might be a mag tape, depending on what type of device it is. And then there's RAID. Now, we talked about RAID in our disk management video. RAID can be either hardware via a controller or an array, so you can have a hardware RAID controller that has a RAID chipset. It has its own configuration and software on the RAID adapter, and it's actually performing the RAID functionality. Or you can have software RAID. Software RAID is when it's built into the operating system. Now, Linux includes software RAID built in the operating system standard, and it can be configured at the boot time or later using the LVM, the Logical Volume Manager GUI interface. So we've reached the conclusion of video number 20. In this video, we talked about configuring peripherals, understanding hardware resources, diagnosing hardware resource issues. We talked about different types of removable hardware like USB, and we talked about power management, and then finally mass storage devices like SATA and SCSI devices. So this has been Administering Linux Hardware, video number 20. Thank you very much.